In this lesson, we're going to discuss the surface area of a cylinder. A cylinder is similar to a prism because you start off with a base, and then you extend the edges perpendicular to the base, and you have the same shape on top. The base, however, is a circle, and since it's not a polygon, it's a circle, has a curved shape. It is not considered a prism, but it has the same characteristics. The surface area is made up of two circles and this kind of curved, I call it a lateral surface going around. So we're going to first off discuss the areas of circles before we move on to the rest of the cylinder. So just a reminder, given a circle, we know the property about a circle, the circumference, the distance all the way around the circle, the perimeter of the circle is the circumference. Circumference of any circle divided by its diameter, the distance across going through the middle, is always equal to pi. That is the ratio. Circumference divided by diameter is a ratio that is equivalent to pi. So if I was to multiply both sides by d, I would get circumference equals pi times diameter. So that's our formula for calculating perimeters or circumference of circle. D is the same as 2r. 2 radii, the radius is the distance from the center to the outside circle to the circumference. So I can always replace d with 2r. And just rearranging the order, 2 pi r is another formula. It's the same formula. One using r, 2r replacing d, or vice versa. So if I was to ask for the circumference of a bicycle tire with a radius of 30, so in other words, the length of the distance around the bicycle tire, you can either double the radius and get the diameter and multiply that by pi, or you could use 2 pi 30, your choice. So you just take your calculator and you type in 60, and you should have a pi button. See if you can find the pi button. You could round off and use 3.14 approximately, but let's practice using our pi button on the calculator. So I type that into my calculator, and I'm rounding it off to the nearest tenth will be 188.5 centimeters. That is the length. So if I was to take a pair of scissors, snip that, and lay it out flat, that distance there would be 188.5 centimeters. So knowing that a bicycle tire has a circumference 188.5 centimeters, we can also see that the distance it travels in one rotation or one revolution is 188.5 centimeters. So if we want to know how far this bicycle rotates in 7 rotations, we would go our circumference multiplied by 7. Let me just give you a little visual for that. You can see here that this bicycle, this tire here in the front, has the arrow pointed down. As it rotates, one full rotation, the arrow pointing down, is equivalent to we're going vice versa, one full rotation is equivalent to the circumference, 2 pi r. That's the distance it traveled. So if we wanted to know how many times it traveled in 3 kilometers, well, this is in kilometers and this is in centimeters, so that doesn't match up. So we need to convert either this to kilometers or this to centimeters. So let's convert kilometers into meters first. We know there's 1,000 meters in a kilometer, so we have 3,000 meters. And we know that there's 100 centimeters in every meter, so therefore we have, multiplied by 100, we're going to get 300,000 centimeters. Or in other words, you can learn that there are 100,000 centimeters for every 1 kilometer. So we've converted that to centimeters, so we go, okay, well, if I want to travel 300,000 centimeters and each rotation is 188.5 centimeters, we can divide that, and I'll type that into my calculator. Oops, 188.5. And I get approximately 1,591.5, so it's 1,591 and half a rotation. I'm always going to round down because even if I had 0.9, I can't get another full rotation in. So I would say at most 1,591 rotations in 3 kilometers. That's how many times the wheel is going to turn. All right, well, what about area of a circle? Area is pi r squared. Where does that formula come from? Well, if I was to look at the area of a circle, think of it like a pizza. I could share this pizza with 4 people, right? I could share this pizza with 8 people. I could share this pizza with 16 people, and so on and so on and so on. Now, if I was sharing it with 8 people, and I cut out all the pieces and I laid them out, in this type of form. So I have 1, 2, 3, 4, 5, 6, 7, 8. What kind of shape does that look like? To me, it looks like a parallelogram. Looks like a parallelogram. So how would you find the area of a parallelogram? The area of a parallelogram is base multiplied by height. And remember, our height is the perpendicular distance to our base. Well, in this case, our height is the radius, right? That distance from there to there, the radius of the circle. So we know our height is the radius. So let's replace this with radius. Our base is 1, 2, 3, 4 crusts of the pizza. 1, 2, 3, 4 crusts of the pizza, or half the circumference. So we know the full, remember circumference is 2 pi r, so that's the full circumference. So if I want half the circumference, then half the circumference is going to be pi times radius. So our area is going to be our base, pi, multiplied by radius, multiplied by our height, or pi times r, or we could write that as pi r squared. Well, a lot of you are saying, but the base is not a straight line. The pizza crust has a curve to it. Well, that's if I only cut it in 4 pieces. If I shared this pizza with 1 million people, 2 million people, up to infinity people, if I start cutting a pizza into infinitely small little pieces, each one of those little edges there becomes straighter and straighter and straighter and looks more like a line. So as it approaches infinity, it does become a line. Okay, so that is the area of a circle based on the shape of a parallelogram and based on the fact that we're cutting this up into infinitely small pieces, making it resemble a parallelogram. All right, so if I gave you a circle with a diameter of 17 and I wanted to find the area of the circle, well, area is pi r squared. We cannot just say pi r squared is diameter. That's not true. 2r is diameter. So we have to use the radius here. We cannot just substitute diameter in. So in this case, my radius is half my diameter. My radius is 8.5. So I would say my area is pi times 8.5 squared. And order of operations says I have to square 8.5 first and then multiply by pi, and we'll get approximately 227 meters squared, right? Circumference is just meters or centimeters because it's a length. It's one-dimensional. Area is square meters. It's how many squares cover the surface. I will have this question in the notes. In class, I have a fun little activity to do on the boards, and we try to figure out how much grass this goat can eat with a shed, and I'll let you look through that on your own if you'd like to. We can also work backwards. If we have a circle and we know the area is 232.2 meters squared, can we find the radius? Yes, we can, because we know area is pi r squared. This is the answer to our formula, and whenever you know the answer to the formula, you can work backwards. So we're going to take our 232.2 and we're going to divide both sides by pi. So when you divide both sides by pi, the pi's undo each other, cancel out, and we get 73.9 is r squared, and the inverse operation to squaring is square rooting, so we take the square root and we get 8.6 approximately is equal to the radius. And so that makes the radius 8.6 meters. Make sure we put the correct unit. Area is square units, meters is length. If we wanted the diameter, we would then just double that. All right, let's move on to our cylinder. So we know the net of a cylinder is this curved surface laid out looking like a rectangle. It's kind of like if this was a soup can, this would be the label of the soup can. Okay, where we could see, what kind of soup it is, and the top and bottom would be the circles, the part we would cut around to open the soup can. So we have two circles and a rectangle. So if this full distance across is the diameter, then half the distance is the radius. So we know that one circle is pi r squared. The second circle is also pi r squared. So rather than going pi r squared plus pi r squared, we're going to say there's two circles. And then we need to add on a rectangle. Well, the height of this rectangle is the height of the cylinder. So that matches up there. The part that's difficult is to figure out this part right here. What is that part? And I showed it to you earlier. If we go back to that visual, we can see that that label wraps around the soup can. And that label length is the circumference, because that distance along there wraps exactly once around the circle. So 2 pi r. I'm going to use the one with r in it because I've used r for my circles. So I'm going to use instead of pi times diameter, I'm going to use 2 pi r. So we go back here. We now know that this distance here is 2 pi r. And to find the area of a rectangle, it's base times height. So we now have the area of that rectangle, which we are going to add on. So the surface area of a cylinder is two circles, 2 pi r squared, plus a rectangle, circumference times height. Circumference multiplied by height, 2 pi r h. So we can just use that formula now when we want to calculate the surface area. So if I gave you a cylinder with a height of 10 and a diameter of 10, so that distance all the way across was 10, we could use our formula. Surface area equals 2 pi r squared plus 2 pi r h. Our r is 5. Since our diameter is 10, we would put 5 in. 2 pi 5 multiplied by height 10. I don't put units into my formulas. I just know that when I put my units in, they're all the same. I'm putting all centimeters. If one of them was meters, I'd convert it so they're all the same. And your final answer, I'd put the units back in. But it gets cluttered when you put units in. So, order of operations, I have to do all the multiplication before I can add. So I'm going to do 5 squared multiplied by 2 pi and get 157.1. And I'm going to do 2 times pi times 5 times 10, and I'm going to get 314.2 approximately. And again, since pi is irrational, these numbers will be irrational as well, so the best you can do is round off and get an estimate, your best estimate for the answer. So when I add those two together, I now get 471 point approximately 3. And again, I look back at questions, centimeters squared for area. Okay, so that's how many squares would fit around the outside. If I had to go buy material to create and make this, that's the amount of material, assuming no waste, to create this cylinder. This is our best estimate because of pi being irrational. If we wanted the exact answer, we would have to leave pi in it. So if we wanted the exact answer at this point, I would have taken my formula and left pi in it. I would have gone 2 times pi times 5 squared, which is 25 times 2, which is 50 pi, plus, and again, I'd multiply out the numbers but leave pi. 2 times 5 is 10, 10 times 10 is 100. And now if I have 50 pies and I'm adding 100 pies, altogether I have 150 pi square units or square centimeters. This is an exact answer. This is our approximate answer. They're the same thing. Math 8, of course, I would take that as absolutely 100% correct. Working on Gauss, sometimes Gauss works in answers like that. If I was to ask for a surface area of a waste basket, meaning how much material is needed, or if I wanted to paint all of the outside edges, how much surface am I painting? But this time there's no lid, so there's no top circle. How would I convert my formula? So I know my formula for an entire cylinder is 2 pi r squared, in other words, 2 circles plus 2 pi r h plus a rectangle, 1 rectangle. Well, in this one, we still have the rectangle, so nothing changes here. We still need the 2 pi r h. But since we only have 1 circle, we're going to get rid of the 2 part on there. So we're going to change this to 1 circle plus the rectangle. If there was no circle on the bottom, like a roll of cardboard in a paper towel roll, and I just wanted to know how much cardboard there was and there was no circles, how would I change my formula? Instead of using 2 circles plus the rectangle, I would get rid of both circles and I would just use the rectangle, or I call that the lateral, the curved surface. And you would just use that portion of the formula. So you'll notice that 2 is always there in this part of the formula because the 2 pi r is the length of that rectangle and the h is the width of that rectangle. So this 2 does not mean I have 2 rectangles, but this 2 does mean I have 2 circles. So be careful there. I'm not going to calculate it all out. We would plug that all in and you guys can work through that on your own. In my notes, I'll have the solutions all worked out for you. The last question I wanted to talk about is, if you have a can and you're putting a whole bunch of, let's say, tennis balls in there, and you know the radius of each, or the diameter of each tennis ball is 6, or in other words, the radius is 3, how much material do you need to make the label or the entire can or something like that? It doesn't matter what I ask. You can, based on last question, you can either figure out are there 2 circles, no circles, or 1 circle. The key here, though, is if these balls fit perfectly in the container and each ball has a radius or diameter of 6, we know that the radius is 3 of the cylinder, but what's this height of the cylinder? Well, if the diameter is 6, there's 3 balls with a diameter of 6 that fit perfectly inside, so that gives me a height of 18 centimeters. If the radius was 3 and I only knew that, I would just double the radius to get the diameter, and there you go. So if I only wanted the label, then I would go, oh, 2 pi r h is the surface area. I'd only use the curved lateral surface. I would not include the 2 circles. And you go 2 pi r h. And you could type that all in the calculator to get the approximate answer, or you could type in 2 times 3 times 18 and leave pi in it for your exact answer. All right, so now you can go to the worksheet and you can practice your surface area of cylinders.